Hi students, good afternoon. Today we will take a important topic in the subject called as linear algebra, where this topic is very important for all the branches of engineering. Called the topic is eigenvalue and eigenvector. The very important topic in all the engineering field, all the branches. This topic is very important. So eigenvalue and eigenvector. What is eigenvalue, eigenvector is? So you already studied about matrices. So we will consider n cross n matrix, a square matrix of order n cross n. Then the definition is Ax equals lambda x. The definition is Ax equal to lambda x, where x is a non-zero vector. X is a non-zero vector called as eigenvector, and the scalar lambda is called as eigenvalue. Lambda is called as eigenvalue. Very easy topic. So we will take the problem. So what we need to do exactly is, a matrix A will be given. We have to find out what is lambda and corresponding lambda. If it is the matrix is n cross n, we will be having n values of lambda. N lambda values will be getting. Corresponding n lambda values, we have to find the corresponding values of eigenvectors lambda, right? So I'll instead of directly we'll go to the problems now. The problem is now we'll take 2 cross 2 matrix. So for 2 cross 2 matrix, we'll get 2 eigenvalues. So the matrix is, this is the given matrix. Matrix A equals 5 minus 5 2 and then 2 minus 2. This is the given matrices. So we need to find an eigenvalues and eigenvectors for this. The formula is what we the formula is definition of eigenvalues, eigenvectors is Ax equal to lambda x, where x is the eigenvector and lambda is the eigenvalue. So now what we'll do? So Ax minus, if we take this side, it is lambda x equal to 0. Ax minus lambda equal to 0. Now again further we can write this one, a minus lambda times x equal to 0. There is a problem here where we cannot subtract a constant from the matrices. That is not possible. So we will multiply it by a identity matrix called as I, where I is the identity matrix of order. What is the order of the given matrix? Now a minus lambda into x equal to 0. Since x is not equal to 0, x is a non-zero vector, then so only possibility is, so we have the tendency where a two numbers, multiplication of two numbers equal to 0. That means that if a is not equal to 0, we will go that b equal to 0. Since it is a matrix, we cannot take completely a minus lambda equal to 0. So that what is the method is, by Kramer's rule, if this is possibility is only when the determinant of a minus lambda I will be 0. The determinant of a minus lambda I equal to 0. So we cannot go like a numbers, this one, right? So now we will substitute the matrix value there and we will find out what is lambda values and what is corresponding eigenvectors. So determinant of a value is, first we will write it, what is a minus lambda I. So a minus lambda I equals the matrix A minus 5 2 2 minus 2 minus lambda times 1 0 0 1. This is the eigenvector, identity matrix. So now if you subtract this, you have to subtract that entry corresponding first entry to first entry. It is minus 5 minus lambda and it is 2 minus 0, then 2 minus 2, right, 2 minus lambda into 0, minus 2 minus lambda into 1. So it is minus 2 minus lambda, right. This is a minus lambda I. For the determinant of a minus lambda I will be, as it is method, you know all of you how to find determinant. So it is easy method. So minus 5 minus lambda times minus 2 minus lambda. So it is minus 5 minus lambda times minus 2 minus lambda minus determinant of product of these two minus product of these two, minus 4. This should be equal to 0, right. So what happens now? if you multiply it is now, so minus 5 into minus 10 it is 10, minus 5 into minus 2, then minus 5 into minus lambda is 5 lambda, minus lambda into minus 2 is plus 2 lambda minus 4 equal to 0. So we got a quadratic equation. Where first it will be lambda square plus 10, 5 lambda plus 2 lambda minus 4. So the equation is now lambda square plus 7 lambda, 10 we have minus 4, that will be 6 equal to 0. So we are getting an equation 7 lambda square minus 7 lambda minus 6 equal to 0. We will solve that quadratic equation. So what we will get? The equation is lambda square plus 7 lambda plus 6 equal to 0. Now the method is, now if you add you should get 7, and if you multiply you should get 1. What are the factors? So we can take it as 6 and 1. 6 into 1 is 6, 6 plus 1 is 7. So it is lambda square plus 6 lambda plus 6 equal to 0. From these two we can take it out lambda constant. So lambda outside. So lambda times lambda plus 6 plus, from these two I will take it 1 outside. So 1 times lambda plus 6 equal to 0, right. So again from these two we will take out lambda plus 6, lambda plus 6 times lambda plus 1 equal to 0. That means that lambda plus 6 equal to 0 and then lambda plus 1 equal to 0. That means lambda equal to minus 6 and lambda equal to minus 1. These are the eigenvalues of the given matrix. Now we have to find the eigenvectors. What is how to find eigenvectors? What is the definition we used? A minus lambda I, it is a matrix, times x equal to 0. So corresponding lambdas we have to substitute in this matrix and we have to find the value of the eigenvectors. So now A minus lambda I is minus 5 minus lambda. You will check in the example what is the matrix. Minus 5 minus lambda, 2 minus 2 minus lambda. So minus 5 minus lambda, 2 minus 2 minus lambda times the eigenvectors are x, y. So since it is a 2 cross 2 matrix equal to, so E0 means we will take it in the column vector 0 0. Now what happens now? First case 1 we have to find out eigenvector for each lambda values. So now we will take lambda equal to minus 6. What happens now? The matrix becomes minus 5 minus of minus plus 6 and then 2 minus 2 minus of minus plus 6 times xy equal to 0 0. So what happens now? If you expand this, so it is minus 5 plus 1 is 1, 2 minus 2 plus 4 is 4, and then so if you multiply this, what I will get is, so it is x plus 2y equal to 0. 1 into x plus 2 into y, matrix multiplication, and then 2x plus 4y equal to 0. You see both the equations almost same. First equation is x plus 2y, second equation is 2x plus 4y. So we will consider any one, x is equal to minus 2y. Since you can take any values of x because it has infinite solution, so I will take it as y equal to k. K is any constant, but k should not be 0, because if I take k is 0, then all the values become 0, that the definition itself fails. Eigenvector should not be 0. Now x is equal to minus 2k. Therefore, the corresponding eigenvector x1 equals x value is minus 2k, y value is k. Right? That is when lambda equal to minus 6. When you take lambda equal to minus 1, the matrix becomes minus 5 plus 1, 2, 2, minus 2 plus 1 times lambda equal to minus 1, we are substituting xy equal to 0, 0, 0 and 0. Now what happens if you multiply it is 4x plus 2y equal to 0 and then 2x plus it is minus 4x, right, and this one is will get your minus 4 minus y equal to 0. Again you look both the equations, it looks same, so I will take y equal to 2x. So now we will substitute x value as k and y value becomes 2k. Now the corresponding eigenvector equals k and 2k. Yeah, this is how we will find out eigenvalues and eigenvectors of a matrix. Thank you.